Hello everyone and greetings. In the previous video, we walked through a quick introduction to animation blueprints. Before we continue with our animation blueprint, however, I wanted to take a moment to talk a little bit about state machines, as creating a state machine is going to be our next step. But I'm going to assume that most of you do not know what a state machine is. So I thought I would take just a moment here to kind of go over the concept to help make things clearer for when we start to put ours together. Hopefully everything will come together and make a little bit more sense. So first of all, what are state machines? So state machines are technically a process by which you could track the current state of any logical process, like a computer program, for instance. You could track what state a program is in, and it can move from state to state, which is exactly what a state machine in Unreal Engine 4 is as well. The problem with defining it that way, however, is if you are a programmer, you kind of already know what a state machine is. And when I say that our animation system uses a state machine, you probably already know what to expect and how it can be applied. However, most animators or designers to some extent, not all, but most, are not programmers. They lean more towards the artistic side of things, so the term state machine may not fully resonate with them. So what we're going to do is generalize things and simplify them down so that hopefully this is approachable by everyone and it kind of makes a little bit more sense. Now, disclaimer time, state machines are a really complex topic and you can go really high-end, crazy overboard with them. You could make a state machine that drove just a single part of a character's body, like their arm, if you really wanted to. We're not going to do that. We're going to keep things very simple and take things step by step here. But the point is that a state machine essentially is really just a graph. That's it. It's a graph that charts out the character's current activity. So when you say, what is the character doing right now? The answer to that question, in most cases, not all, can generally be thought of that character's state. This would include things like running, for example, or jumping, or swimming, or any number of different things. Now, depending on how you're looking at your character, I'd imagine if you're watching this video, you already have a game that you want to make. You've already got a character that you want to include, and you've got a laundry list of things that you want your character to be able to do. So let's say you wanted your character to be able to punch, right? Well, you might be asking yourself, well, shouldn't my character have a state that is punching? I mean, that seems like a logical decision to make. Well, chances are you probably won't want your character to be able to just punch, and that's it. Typically, in most games, if a character is punching, they could also be moving around or jumping or doing any number of different things while they are punching. So if you try to describe that or actually say what a character is doing in a sentence, if I said a character was running around and punching, I'd probably write that out something like the character is punching while walking. Or maybe the character is punching while standing still or punching while running. There's all different kinds of things he could be doing while he's punching. It's really the while part here that is the most important aspect. This would actually be considered the character's state. And the punching activity would actually be layered on top of it. That would just be an extra thing. So this is where state machines can get a little bit complicated, and I don't want you to get too bogged down in that. What I like to do is keep things very simple while we first get started here. We're going to build a very simple state machine to kind of get things going. And then over time, as you come up with more things for your character to do, then you can start seeing how you can add in more states and make things more complex. So what we're going to have, well, actually, let's just step through the process here together to kind of help visualize things. We're going to have a few very, very simple states. So let's start out with our first state here. And we're going to call this state the idle, walk, run state. Now, as the state suggests, it's going to handle our idle, walking, and running animations. And you might be asking yourself, well, why is this one state going to handle all of these things? Well, that's because we already set up all of those activities, if you recall, into our blend space. So that blend space is going to be self-contained inside this state, which means as long as the character is doing any one of those, he could be standing still, he could be walking, or he could be running, he would be considered in this particular state. Now you might be asking yourself also, well, why didn't we just make 3 separate states? One for idle, one for walking, and one for running. Well, there's really nothing stopping you from doing it this way. You could totally set it up that way if you prefer. The problem with doing it that way, however, is that you don't have the nice smooth blend ability that a blend space offers. That's why we took those three motions and instead of making them separate states, we put them into a single blend space. Now that blend space can drive a single state and we get nice blending. Whereas if we had something more like this, say for instance, we had our idle state and then we had a walk and we also had a run. We could totally set up some rules and say, okay, when the character is moving at a speed that is greater than 95, then we want the character to start walking. As soon as the character's speed is greater than or equal to 375, then he could start running. And obviously when speed is 0, then he would go back to idle. We could totally do it this way. There's no real problem with setting up that way. The only catch is we wouldn't have that nice blend animation that our blend space offers between those states. That's the real hassle there. Since we needed blending, we put everything into a single blend space node, and that one blend space node, which holds all three of those animations, can be used for the state for our character to enter. Now, the other main thing, since we're not going to worry about swimming here, let me go ahead and kill that. We don't have any swim animations anyway, so we are really only worried about running and jumping. Now, jumping is kind of fun. There's a bit of a catch to it. We have a problem to solve. We never really know the answer to this question here. How long is the character going to be jumping? How long are they going to be in the air? We really don't know. The only way to solve this problem is say, for example, let's take a jump here. So that's our jump motion. And here's our character who just got finished jumping or dancing, depending on how you look at my drawing there. But he's happy because he just got finished jumping. We're going to take this jump and cut it up into three parts. We're going to have a jump start, a jump loop, and a jump end. Now the reason we're going to do this is we could have a scenario where the character jumps on a flat surface, similar to this, and then we would have the exact same jump time. That's really not a problem. But what if the character was doing something a little more like this, where the character had to start up here and jump all the way down like so? Then our jump start time is always going to be the same. Our jump end would be relatively close to the same as well. But it's this time in the middle here that could really be any amount. It could be really far or it could be really short. The character jumping off of a tall building versus jumping off of a curb, for example. That's really a variable. So what we're going to do is actually just take this jump loop here and, as the name suggests, loop it over and over again to make up for any amount of time that the character must fall. Now the other nice useful part of this is, as I slide my examples over here a little bit, let's say we had a big ledge and the character happens to be walking and not paying attention and walks right off the ledge. He's still going to need to do some sort of falling motion, and that falling motion will be consumed by our jump loop as well, after which he can go into his jump in or his landing. So in this way, by taking our jump and breaking it up into three different things, we can play each one as long as we need to. All right, so now with that in mind, we know that a state machine is a graph of our character's current activity, but there's a little bit more to it than that. It's also a series of rules called transition rules, and these control how you get from one state to another. So we are going to, say for instance, have another state here, and we're going to call this state the jump start. And the character could at any point go from idle walk run to that jump start state. So the behavior moves in this direction, but how do we get there? Under what circumstances would he go into jump start? Well, we'll simply ask the game a question. Let me kill this blend space here to make more room as well. Our question to the game is going to be, is the character in the air, yes or no? If the character is in the air, then we go ahead and start playing the jump start animation. Then we would have another state, which we'll call jump loop. And the character will always go from jump start to jump loop. It's just the next thing that he's going to do. It's the nature of the transition. But how? Under what circumstance? What's the transition rule to get there? Really, we're going to keep it very simple. And all we're going to say is when the character gets near the end of the jump start animation, continue on to the jump loop automatically. Now, remember how we took our jump and we cut it up into three parts? Once we get towards the end of the jump start animation, we can just automatically go ahead and move him over to the jump loop animation. So following the jump loop, the next logical state we would have is our jump end state. And the jump end is simply going to be fired by asking, are we still in the air? And if the answer is no, then we're going to go to the jump end animation. So let's actually put that in parentheses here for clarity. Are we not in the air? And finally, our next transition out of jump in would be to go back to our idle walk run state here, since we are no longer jumping. And the transition rule for that would be, are we near the end of our jump into animation? And if so, go ahead and proceed to the idle walk run state. So really, with that, if you step back and look at it, our state machine would have 4 states, but really there are 2 different things he's going to be doing. We've got moving and we've got jumping. And really, if you wanted to, you could make a state machine that did this and had one transition rule that went this way and another that went back the other way. What you could say is the character's still in the air, and if they are, start playing the jumping animation. As soon as you're not, go back to the moving state there. The catch with this is that it would not take into account all the different ways in which you could jump, because you could jump up onto something and spend very little time in the air, or you could jump down from something else and have a lot longer time in the air. So this is why we took that jump and split it up. And then the nice blend space that we have is just a way for us to get nice smooth blending based on a speed value, the speed of our character. Which, had we used 3 different states for idle, walk, and run, which could be done, I don't want to say that it can't, it just wouldn't give us that nice smooth blend ability that our blend space offers. So with all that wealth of knowledge under our belts, I know that was a lot to take in, recapping really quickly here before we close. State machines are just a way to take the general stack of activities that your character is going to be doing, and then create a graph of each one of those activities. Then also creating a series of rules that will allow the character to move from one of those activities to another. Now that we've gone through that, we're actually going to pause here. And when we come back, we will hop inside the editor and go through the process of creating our state machine, which is going to look almost identical to the one on the left of our screen here. So the process should be relatively quick. So with that, let's go ahead and pause, and we'll continue setting up our state machine in the next video. We will see you then.